Okay, so this section is section 6.4, which is dealing with special factoring. Okay. I think they're all pretty important, but the one that we emphasize a lot, okay, especially when you get into the um, intermediate college algebra, calculus, things like that, is the difference of two squares. I think that's probably the most popular factoring that we do that helps us solve problems. All right, so the difference of two squares says if you have a squared minus b squared, then you can have break them down to a minus b times a plus b. Okay, so a minus b times a plus b. So for example, if I have if I had say y squared minus 49, right? I can rewrite this as y squared minus 7 squared. Okay. All right, and notice that this is going to match the a squared minus b squared. So the y here is going to represent a, okay, and the 7 here is going to represent b, okay? So that will be a squared minus b squared, okay? If we were to use the formula, which is a minus b times a plus b, okay, so let me just take this and load that. Try that again. Okay. And apply the formula, we get a minus b times a plus b. Okay, so again, a in this case is going to give me by and b is 7. So by minus 7 and then y plus 7. Okay, so that would be our difference of squares. And of course, you can always multiply them out. Okay, and you'll go back to where you started, which is y squared minus 49. So if you want to FOIL this out, you'll get the same result as y squared minus 49. Okay, so the next one is called a perfect square trinomial. Okay, and what are the key indicators would have to be is that the first term and the last term are perfect squares. Remember what is a perfect square? Okay, so 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, 25 is a perfect square. Okay, so if I were to say use this example, let's say 25y square minus 30y plus 9. Okay, let me rewrite that. 30y plus 9. All right, so what I'm going to look at is the first term and the last term. Okay, so the first term and the last term. All right, so notice that 25 is a perfect square. We wrote that down here, right? It's a perfect square. And also notice that 9 is a perfect square. Okay, all right. So when we factor this, we're going to have the same factors. So in this case, we have a minus positive combination. So we're just going to have as our answer a minus b squared. So in this case, 25, when I take the square root of that, it's going to give me 5. Okay. And then same thing here, when I take the square root of 9, it's going to give me 3. Okay. Now, we can't forget about the variable. Okay. So that's going to be y. Okay. So basically what I'm doing is I'm just taking the square root of the first term and the square root of the last term. Okay, so 25y squared, the square root of that is going to give me 5y, and the square root of 9 is going to give us 3. Okay, so we have a minus positive combination, right? Minus positive. So we're going to have two negative factors here. All right, and then I can rewrite this as 5y minus 3 raised to the second power. Okay, so as long as the first term and last term, okay, um, are perfect squares, then we're able to use the perfect square trinomial formula. All right, so the last one here is we're going to look at the sum and difference of two cubes. Okay, so one example, let me copy this here and put this in another slide. Okay. Okay, so one example is y cube, again, I'm doing the one down here, y cube plus 27. Okay, and again, they want us to factor this out. Well, I'm going to rewrite 27 as 3 to the third power because 3 times 3 times 3 is 27, and I'm going to have just y3 and rewrite it down here. Okay, and these are being added. But the key part here is we do want to factor. Okay, so if we follow just this here, we have a positive, so we want to use this one. Okay, it corresponds with this. So let's write this out. A plus B and then a squared minus 2ab plus b squared. Okay, so we wrote down the formula a plus b times a squared minus 2ab plus b squared, and then we had the y cubed plus 27, and then we rewrote it as y cubed plus 3 cubed. Okay, so in this case, then this is going to be our a, the y, and then b is going to be the 3. And we just plug it in. So if you can get to this point here, okay, and then just use the formula, you're good. All right, so use that different color here. All right, so we said A was Y. We said B is 3. All right, and then A again is Y squared, and then 2AB. All right, that's going to be 2 times 3. Goodness gracious. 2 times Y times that by 3. Okay. And then B is going to be 3 squared. Okay, so let's go and simplify this. We get y plus 3 times that by y squared minus 2 times y times 3 is 6y plus 9. Did I do something? Oh, I added a 2 there. There shouldn't have been a 2 there. I was copying the other one. My bad. There shouldn't be a 2 there. I was copying this up here. It should have been down here. My bad. So anyway, that should have just be a 2. I mean, there's no 2 there. So this should be a minus 3y. Okay. All right, and then close the parentheses. All right, and then that's all you do there. Okay. Sometimes this right side is factorable, but in this case, it's not. If it was, then we would have another two factors. If it was, say, minus 3 or something, and 4, y minus 3 and y minus 4, something like that. That's not. But anyway, we would just leave it like this, okay? If we can factor it at all anymore. Okay, so again, just to recap here, oops, you have the difference of two squares, okay? So the difference of two squares is like y squared minus 49 or x squared minus 64. Right? As long as a minus is in the middle, then you can break it down to two factors, a minus b, a plus b. So that's the difference of two squares, okay? Right? Because again, this number here, it has to be a perfect square, 49, okay? In order for it to work. The other one is the perfect square trinomial. That just means that the first term and the last term are perfect squares. Remember, the perfect squares are 1, 4, 9, 16, 25, 36, so on and so forth. So multiplying the number to itself will produce a perfect square. Okay? All right. Anyway, so once you have the perfect squares, then you're going to have the same two factors. And you just rewrite it as just that one single factor and then raise it to the power of 2. Okay? And then the sum on difference of two cubes is when you have something like this, it's like y to the third plus 27, right? Or y to the third plus 8, because 2 times 2 times 2 will give me 8, right? So anyway, so identifying which is your A and your B. So y would be our A, and then if we rewrote 27 as 3 cubed, then 3 would be our B. And then just a matter of just matching it with the formulas and plugging it in. Okay. All right, so let's go through this. Okay. So for the first one here, we have z squared minus 81. Okay. So if I look at my factoring, formulas here, this one's going to match the first one, right? This one here. All right, so I just need to rewrite this as z squared minus 9 squared because 9 times 9 is 81. Okay. Now I can just factor it. So that will be a minus b times a plus b. Okay. So in this case, my a is z. So that will be z minus, and then my b is my 9. So z minus 9. For my a plus b, that would just be the opposite, z plus 9. And that's it. So these will be my factors. All right. Because this is a perfect square. All right. Well, you might say, well, what about the bottom? That's also a perfect square. It's true. However, now we have a power of 3. So that means that we need to use one of these ones down here. Okay. So I look in the middle of this binomial, we got a negative. So that looks like I'm going to use this one in the bottom. Okay. So, but first I need to break this down because it says a cubed minus b cubed. So this would be n cubed. Okay. And I need to figure out, okay, what can I multiply to itself 3 times to give me 64? Okay, so that would be 4, right? 4 times 4 is 16. 16 times 4 is 64. Okay, all right. So I'm going to rewrite this as 4 to the third. Okay, now it's just a matter of just plugging in that information. My n is going to be a, and my 4 is going to be my b. Okay, so again, I'm doing this here, so that would be what? Um, n minus b, or n cubed minus b cubed. Okay, oh my gosh, 4. Like saying b. N cube minus 4 cubed. There we go. Okay, so then this is equal to n minus 4. All right, I'm running out of space. Let me move this here. Just- So again, we got n cubed minus 4 cubed. That's the a cubed minus b cubed. And then now I'm focusing on here. So that'll be n minus 4 times that by n square plus AB. So that will be 4n plus 4 square. Okay. Now I just simplify this a little bit. I get n minus 4 n square plus 4n plus 16.